Welcome to this explainer. Listen, today we are tackling what is arguably the ultimate, most frustrating challenge for Cambridge computer science and information technology candidates anywhere in the world. And it doesn't matter if you're currently studying syllabus codes 0417, 0478, 2210, 9618, or taking on the AS and A-level 9626. There's this one specific area that just consistently trips up even the absolute brightest, most prepared students. I'm talking about mastering syllabus topic 2.5, Graphical User Interfaces, or GUIs for short. Now let's face the harsh reality for a second. You might be sitting there thinking you know all about interfaces because, well, you interact with them on your smartphone all day long, right? You know what a button is, you know what a menu is, but here's the catch. Cambridge examiners are not looking for your everyday, casual opinions on app design. They are hunting for precise, rigorous, and deeply connected understanding. This specific topic appears in every single examination series without fail, literally every time. It is a massive source of potential marks, and yet year after year, candidates walk out of that exam hall feeling super confident, only to open their results months later and realize they completely missed the mark. Today, we're going to change that. We are going to read the warning signs together, unpack the actual examiner reports, and give you the exact step-by-step strategies you need to avoid the common pitfalls that are absolutely sinking grades. Let's get right into it.
Right off the bat, let's look at a direct quote from the very people who hold your final grade in their hands, the Cambridge Principal Examiner reports. They state, and I quote, "Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This isn't just a casual suggestion, this is an urgent flashing red alert." Let me translate what the examiner's actually telling you here. They're saying, do not ever assume the person grading your paper knows what you mean, and definitely do not assume that just throwing around tech buzzwords is going to magically earn you marks. It won't. If you decide to mention a WIMP interface in your answer, windows, icons, menus, pointers, you need to explicitly define what those specific elements are in the exact context of the scenario they gave you. If you start talking about intuitive design or cognitive load, you must stop and establish clear academic definitions before you even attempt to build your argument. It's crazy how many students are constantly losing easy fundamental marks because they just skip the definition phase and sprint straight into their final conclusions. Don't be one of them.
To really illustrate this trap, let's take a look at two hypothetical but very realistic example students. We'll call them Alex and Sam. Now, Alex is a seriously hard worker who basically memorized the entire computer science textbook. But when faced with a question about designing a GUI for, say, a busy hospital management system, Alex completely panics and overloads the page with raw facts about touchscreen technology, completely ignoring the hospital context entirely. Alex provides zero critical analysis, just a massive, unstructured brain dump of superficial facts. They're writing furiously, getting hand cramps, but scoring almost nothing. Now, Sam's approach is entirely different, but honestly, it's equally flawed. Sam looks at the clock, rushes, sees the acronym GUI, and completely misses the crucial command word at the start of the prompt, which was evaluate. So Sam writes two incredibly quick sentences that completely ignore all the formatting conventions required for an extended response. The end result? Both Alex and Sam lose massive amounts of points. This is the classic trap, but stick with me because today we are going completely under the hood to build your escape route.
Here is our masterclass structure for today. First, we'll cover core GUI principles. Second, the procedural framework. Third, evaluative thinking. Fourth, we'll do an interactive workshop. And finally, we'll hit the top examiner traps and the final system.
Section 1. Core GUI Principles. Let's look at the theoretical foundations.
Okay, so this is the foundational theory you absolutely must internalize to avoid the conceptual traps that totally ensnared our students Alex and Sam. We need to completely reset how you think about the syllabus right now. You simply cannot view these topics in isolation anymore. The crucial overarching conceptual goal here is what we call connected understanding. The Cambridge syllabus emphatically states that top-performing students exhibit the ability to grasp causal relationships and integrate GUI principles seamlessly into completely unfamiliar exam contexts. So what does this actually mean for you when you're sitting at that desk? It means that if the exam throws you a curveball and asks about designing a GUI for a self-service checkout in a chaotic, noisy supermarket, you can't just write down a generic list of interface rules. You have to actively connect the GUI design to those specific environmental constraints. For example, how does the intense overhead screen glare in a supermarket affect your color contrast choices? How does the lack of a physical keyboard change how you handle data entry validation for a customer who is in a rush? Examiners explicitly, and I mean explicitly, reward candidates who can make these logical, cross-topic connections with significantly higher marks. Let's break down how you are actually being assessed behind the scenes. The assessment objectives for GUI topics target 3 very distinct cognitive domains. First up is knowledge and understanding. This is just the basic definition of terms. Honestly, it's the absolute lowest tier of the grading pyramid. Rote memorization only gets you this far, and it's not very far at all. The second domain is practical application. This is where you actually take those definitions and apply them directly to the highly specific scenario provided in the exam prompt. And third, the absolute pinnacle, is critical analysis. This is exactly where the top grades live. This is where you evaluate the effectiveness of the interface, anticipate where a user might make an error, and logically justify every single one of your design choices. Think about it. If your current revision strategy only focuses on that top bullet point, just endlessly flipping through flashcards and memorizing definitions, you are literally leaving over 60% of the available marks sitting right there on the table.
The academic benchmark you have got to reach requires a massive mindset shift. You have to move away from superficial breadth. Superficial breadth is just listing isolated GUI facts one after another. Remember our student Alex? This is Alex writing down absolutely everything they know about drop-down menus without ever pausing to explain why a drop-down menu is actually a terrible, dangerous interface choice for a user who is currently driving a car. The Cambridge Assessment Framework actively penalizes this kind of scattergun approach. Instead, what the examiners prioritize above all else is analytical depth. They want to see logical, highly structured reasoning and evaluation. They want you to take just one specific GUI element, tear it completely apart, analyze its pros and its cons strictly within the given scenario, and then deliver a rock-solid, justified conclusion. In these extended responses, I promise you, depth always beats breadth.
Section 2, the procedural framework. Let's get into the technical methodology.
All right, here is your 5-step standardized sequence for tackling literally any GUI question they can throw at you. Step 1, deconstruct the question. Take your pen and physically circle the command words. Are they asking you to identify, describe, or evaluate? Know your mission. Step 2, extract data. Pull the specific, unique constraints directly out of the scenario. Step 3, select framework. We'll talk about the absolute best framework to use in just a moment. Step 4, execute analysis. This is where you write out your clear, logical working. And finally, Step 5, present findings. Now, I need you to pay very close attention here, because this is the insider secret. Following this exact process from start to finish generates crucial method marks. In Cambridge exams, examiners actually award marks for your process. Even if your final recommendation at the very end of the paragraph is slightly off the mark, if you have systematically deconstructed, extracted, and analyzed, you will rack up method marks all along the way. Your process is your ultimate protection.
We also really need to zoom in on Step 5 of that framework, presentation. Strict conventions must be followed here if you want those top marks. We're talking proper headings, the correct terminology, appropriate formats, and crystal clear annotations. Look, practical application in IT and computer science is all about developing professional skills. If you are asked to design an interface layout or evaluate an existing one in an extended written response and you fail to apply the correct formatting or you fail to use clear annotations, it will immediately sink your grade. The examiner is simply not going to hunt through a massive, unformatted wall of text to try and find your one brilliant point. If it is not structured professionally, as far as the grading scheme is concerned, it doesn't exist.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3, Evaluative Thinking, the Critical Analysis Transformation.
Top-scoring candidates, the ones securing those elite grades, do not just accept the prompt at face value. They demonstrate true evaluative thinking by consistently doing 3 specific things. First, questioning assumptions. If an exam scenario suggests using a voice-activated GUI in a public library, a top student immediately spots the flaw and questions that assumption based on the obvious quiet environment constraint. Second, considering different perspectives. How does an expert user experience this GUI compared to a complete novice? How does a visually impaired user experience it? You have to look at it from multiple angles. And third, justifying decisions with concrete evidence. You never, ever just write, "This GUI is better." That gets you nowhere. You write, "This GUI reduces cognitive load by utilizing familiar iconography, which is supported by the fact that." You must rigorously and logically justify every single one of your design decisions.
Let's actually look at a live transformation to show you what I mean. A highly flawed, low-scoring draft might say something like, The screen has big buttons, so it is easy to use. It's full of vague terminology and has absolutely zero links to the scenario. Now, a transformed top-tier answer uses the Peel framework. Point, evidence, explanation, link. It reads like this. Point. The interface utilizes enlarged high-contrast navigation buttons. Evidence. This directly addresses the scenario's constraint of elderly users with declining motor control. Explanation. By increasing the hit area of the interactive elements, the system significantly reduces the risk of accidental inputs. Link. Therefore, this design choice directly improves task efficiency and user satisfaction in the proposed healthcare setting. Just look at that difference. It's night and day. That right there is exactly how you make the brilliant cross-topic connections that examiners are desperately waiting to see.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Interactive Workshop. It's time for some practical application.
To survive the high-pressure environment of the exam hall, you need a mental model that works instantly, on demand. I want to introduce you to the ultimate problem-solving matrix specifically designed for those dense, overwhelming GUI challenges. It's simply deconstruct, solve, evaluate. When you turn the page and are hit with a massive, highly intimidating exam question featuring complex charts or multi-page scenarios, you absolutely do not panic. Instead, you run this mental matrix. You deconstruct the prompt to find the core variables and constraints. You solve the problem by meticulously applying your technical knowledge. And finally, you evaluate to ensure your proposed solution actually makes logical sense in the real world. It's your ultimate mental shield against exam anxiety.
Let's run a quick 30-second speed challenge right now. The checkpoints are identify given information, break into logical steps, solve systematically, check for reasonableness, and make justified recommendations. Imagine you are presented with a flawed paragraph about a bank ATM interface that uses tiny text and highly complex drop-down menus. The moment you see that, your brain should immediately fire through these checkpoints. Information. Okay, it's an ATM. Logical steps. What are the environmental factors? Well, there's severe sun glare, the users are usually rushed, and security is a major concern. Solve. The tiny text completely fails under the sun glare. Reasonableness. Complex drop-down menus are absolutely not reasonable on a laggy ATM touchscreen. Recommendation. Implement a high-contrast, high-hit area button interface instead. Boom. Just like that. 30 seconds. That is exactly how fast and sharp your evaluative thinking needs to become, and the only way you get there is by relentlessly practicing these 5 specific checkpoints on real past paper questions.
Section 5. Top Examiner Traps and the Final System. Let's bring it all together. We have meticulously pulled the most critical, mark-draining warnings straight from the principal examiner reports for you. The top 3 fatal mistakes that candidates make over and over again during the exam are surprisingly straightforward. Trap number 1. Using the wrong approach for the context. This happens when you memorize a rigid rule for a desktop GUI and then blindly apply it to a smartwatch interface. It's a fatal error. Trap number 2. Forgetting to check your format and presentation. You write out an absolutely brilliant evaluation, but you bundle it into one massive, unreadable, chaotic paragraph without any headings. Again, a fatal error. And trap number 3, which is quite literally the biggest killer of them all, answers are not specific to the given scenario. Listen to me on this one. If you give a generic, textbook answer that could technically apply to any software in the world, you will get 0 marks. Your answer must lock perfectly and uniquely into the specific scenario the exam paper provided. And this naturally brings us right back to the ultimate examiner alert rule we discussed at the very beginning of this explainer. Always define your terms before using them. Never assume the examiner knows what you mean, and never assume they'll give you the benefit of the doubt. Explicitly define your GUI terms right at the start of your extended responses. Building this single habit into your writing routine will entirely save you from the vague terminology trap, and it instantly elevates the academic tone of your entire paper.
So how do we tie all of this powerful information together? I am presenting to you the ultimate computer science success blueprint. These are the 3 non-negotiable rules that guarantee top marks when you're executing your exam answers. First pillar, command word decoding. You have to stop missing the subtle difference between describe and evaluate. Circle the word physically on the paper and know exactly what level of detail it demands. Second pillar, Peel framework application. Point, evidence, explanation, link. I want you to promise yourself you will never write an unsupported floating point ever again. Third pillar,
time management matrix. Run the deconstruct, solve, evaluate sequence systematically every single time so you don't accidentally spend 20 precious minutes completely overthinking a 4-mark question. If you master these 3 steps, your mark potential goes from a chaotic 50% right up to a consistent, predictable 100%.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
Which leaves us with one final, incredibly vital question to consider as you wrap up your study session for today. Are you really ready to apply the deconstruct, solve, evaluate framework to your next completely unfamiliar exam question? Don't just sit there and nod along with me. Actively challenge yourself right now. Pull up a past paper tonight. Find a complex, weird, GUI scenario you've never seen before and test your new methodology. Step away from the superficial facts, dive deep into the analytical depth we discussed, and start actually securing the marks you deserve. Keep practicing, keep connecting those core concepts, and you will absolutely master the syllabus. See you next time.